hope you're doing well. Today we are going to start talking about scale factors and scale drawings. So scale factors and scale drawings allow us to use plans that were given in the world, such as a floor plan or some sort of architectural plan or a construction plan, and they allow us to scale up to find out how big something is in real life. So we're going to look at some examples of that today. So a couple of vocab words first. First, a scale factor is a number which multiplies some quantity. So for example, if you had a scale factor of 2, you would multiply every single number by 2. A scale drawing is a drawing where the dimensions are proportional to the actual size of the object being drawn in a predetermined ratio. So when we put those together, what we have is we have a scale drawing that when we multiply all the dimensions by the same number or its scale factor, we're going to get the actual size of the object, how large or how small that it actually is. So, example 1. Bob and his family plan to drive across the state of North Carolina. In his atlas, Bob notices that 1 centimeter is equal to 75 kilometers. So, how many kilometers will Bob and his family drive? Well, what we want to figure out, how long is North Carolina in centimeters? So we noticed from the west to the east on our ruler is going to be 10 centimeters. Well, if each centimeter is equal to 75 kilometers and we have 10 centimeters, all we need to do is take that 10 centimeters, multiply it times 75, and we get a total of 750 kilometers. Well, now, if 1 kilometer is equal to 0.62 miles, how many miles will they drive? Well, we need to do the same thing. Since we know 1 kilometer is equal to 0.62 miles, we're going to take our total amount of kilometers, or 750, and multiply by how big each mile is. So 750 times 0.62 gives you 465 miles. Now, if Bob averages a speed of 60 miles per hour, how long will it take them to travel across North Carolina? So now this one looks a little bit different because he's traveling 60 miles per hour. So instead of doing multiplication, what we're actually going to do is division. We're going to take our 465, we're going to divide by 60 since he travels 60 miles an hour, and that's going to give us 7.75 hours. Now we can look at it in terms of planting a garden. So Kevin is planting a garden. He draws a plan for the garden that is 3 inches wide and 5 inches long. He plans for each inch to equal 2.5 feet. So what are the dimensions of the actual garden? Well, what we have to do is we have to take into consideration the length and the width. If you are given a scale drawing, the first thing you need to do, right, is convert, using the scale. So convert from inches to feet. And since it's each inch is equal to 2.5 feet, all we need to do is multiply both of these quantities by 2.5. So our length is going to be the 5 inches in the picture times the 2.5, since each inch is equal to 2.5 feet, which equals 12.5 feet. And then the same thing for the width. Well, in the picture, it's 3 inches times the 2.5 feet per inch equals 7.5 feet. What is the area of Kevin's garden? So we know area is length times width. Well, now we have to figure out, what do we want to use here? Do we want to use the 3 inches and the 5 inches, or the 12.5 feet and the 7.5 feet? Well, because it asks for the area of his garden, you have to use the real dimensions, which are going to be these feet here. So if you want to calculate area, or later you want to calculate volume, you have to find the actual length of the sides first. So our area is going to be our length times the width, which is 12.5 times 7.5, right? Those actual dimensions of the garden, which gives you 93.75 feet squared. So what if Kevin decides to spread soil in his garden at a depth of 0.5 feet? While at the store, he finds that each bag of soil costs $9 and will cover 25 cubic feet. So how many cubic feet of soil will be needed? So when we say cubic feet, remember our units of volume are cubed. So it says cubic feet, we're essentially looking for the volume of the garden. So remember, our volume is the area of the garden times the depth of the soil, or length times width times height. Okay? We found that the area of the garden on the previous slide is 93.75. Okay? Our depth of the soil in this problem is 0.5 feet. Okay, notice this is the actual depth of the garden, not a scale. We multiply them together, we get the volume is 46.875 feet cubed. Now what we can do is we can use the volume in order to figure out how much soil that Kevin needs to buy. So how many bags of soil must Kevin buy at the store, and what is the total cost? Well, again, we know that each bag covers 25 cubic feet. Okay? So we have to take our cubic feet and divide by 25 to figure out how many we're going to need. Well, that's 1.875. But remember, you can't buy 0.875 worth of a bag of soil at the store. So Kevin's going to have to buy 2 bags of soil at the store. And then if we know each bag costs $9, our cost is the cost per bag times the number of bags, or 9 times 2, which is $18. Okay, so it's going to cost Kevin $18 at the store. So in a problem like this, you must start by converting your dimensions from the picture to the units of the actual garden. Okay? Multiply the length and the width to find the area. Multiply by the depth to find the volume. Okay? Divide the volume by how much each bag covers, and then multiply that by the cost per bag. Diane decides to build a rectangular swimming pool. The pool store manager shows her a drawing in which the pool measures 6 inches by 2 inches. The scale factor of the drawing is 1 inch to 4 feet. What are the dimensions of the swimming pool? So again, what we need to do is we need to take our length and our width, okay? And in this case, multiply each of them by 4, since 1 inch is equal to 4 feet. So our length is going to be 6 times 4, which is 24 feet, and that means our width is going to be the 2 inches in the drawing times the actual 4 feet each inch represents, gets you 8 feet. Now, what is the square footage of the bottom of the swimming pool? When you see square footage, that means you're talking about area. Okay, so remember, area is just our length times our width. 24 times 8 gets us 192 feet square. Okay, so you can go ahead and go online and go ahead and try the problems in the PowerPoint. Have a good day.